Hello, everyone. Welcome to today's webinar on culverts and the hydrology toolset. This is going to be featuring our new version 11 software and some of its functions. Just to let you know, version 11 is releasing on Monday of next week. We're super excited. And yeah, today we're really going to, deep dive into one of the major new functions within that new version, and that's the hydrology tools. So thank you for your patience. If you were ready to attend this webinar last week, due to some internet challenges, we ended up having to postpone it at the very last minute. So thank you for being here today with us. And if you're watching this online in the future, yeah, thanks for checking it out off our YouTube channel. Just a reminder to everyone in the call, we'd love for you to ask questions. So please type those into that GoToWebinar questions section. We'll tackle them at the end. And for our YouTube viewers, you're welcome to ask questions in the comment section below. We will get to them. So for those of you who don't know me, my name is Erin. I'm sort of our resident webinar host, and maybe I'll pop my camera on for a second just to say hi. So I'm our resident webinar host here at Softree. Oh goodness, you probably don't move that over there. Yeah, and with me today is Matthew Dickey. So he is our training manager, and he really does take the lead on all of the technical content for our English webinars. So welcome, Matt. And with that, I'll turn my camera off and we'll get right into the presentation. So today's content plan, first we're going to start with an overview of our hydrology and culvert tools. So I'm gonna give you sort of a quick introduction to what they are and what they can do. And then I'm going to pass it over to Matt for a live demonstration of the new version 11 software. We're going to start by looking at some existing topo surfaces that actually have existing roads in them and use that to explore some of the hydrology tools and what they can do. Then we're going to move over and take a look at hydrology and culvert tools in a design context together and look at some of the really fascinating functionality that you can leverage to really understand the impact of your road on the surface and on drainage patterns. So with that, I'm going to get us started. So version 11 features 5 new hydrology tools. These tools can really help you, understand key considerations with drainage in your project. So the first 4 of them are available through our hydrology tools drop-down menu on the terrain modeling tab. And with that, we've got watersheds, drainage area, streams and ponds, flow paths, and then the last one, and I've kind of denoted it in a different color here, hydro enforcement. And that one really is a feature property that you can apply that allows you to make features hydro enforced, allowing flow through them. And we'll discuss each of these really briefly now, just to help you understand it. But first, all of these hydrology tools operate a little bit differently than most of our functions within the terrain module. For the most part, when we're doing things in terrain, we're looking at your surface as a tin model. So that's a triangular, irregular network. And the hydrology tools really do take a different approach. So instead of dealing directly with triangles, these tools use your terrain as a grid of rectangular cells. And the level of detail on that grid really does depend on the cell size that you are choosing when you're running the hydrology tools. So as shown here in the middle image, with a 10-meter grid, obviously we're losing a lot of detail in that type of larger cell size. So less detailed representation, whereas something smaller like a 1-meter grid looks in this case a lot more similar to our terrain model, our tin model, I should say. So finer detail with smaller cell size. Obviously, both of those have a trade-off in terms of memory and problem size that you're able to run. So just to be aware that this exists as a limitation of hydrology tools and as a variable that you have to control when you're working with them. So the tools themselves, watersheds. If you were with us for our version 11 preview a few weeks back, I am reusing some of the slides, but just wanted to really, high level include them from an understanding perspective, especially for our new folks here today. So we've got watersheds. This is a tool that allows you to create features for independent catchment areas on your tin surface. So this can be really important for knowing the locations of watersheds for drainage management and understanding as well how you can minimize the environmental impact of your road, especially if you end up modifying some of those watershed boundaries with your road surface. So we've got a watersheds tool. This was in version 10. We totally redid it. It's more accurate with new algorithms, and probably the best part is it is substantially faster. The next feature in our toolkit for hydrology is drainage area. And this one's really useful, especially when you're working with culverts to understand what the drainage area that feeds that culvert location is. So you're able to calculate that to a point, like a culvert, or if you wanted to calculate the drainage area to a larger feature or a linear feature, you can do that. It also calculates the most hydraulically remote flow path as well as the centroid. So that's the drainage area tool. You can also run this with a list of features. So if you've got, say, 5 culverts, you can select all your culverts in terrain and then, run it to get the drainage area for all of the culverts and create the features. Streams and ponds. This one, is a really, useful tool. Again, redone from version 10, more accurate, substantially faster, and it gives you the expected location of streams in your tin model, as well as locations, of course, where the water would pool, and we represent those as ponds. So this tool is very useful, in particular when you're looking for where to put a road. You can leverage this in a workflow with Path Explorer, and we'll talk about that one if you haven't seen it. There's a webinar coming up in 2 weeks on Path Explorer. So we'll talk a lot about how you can use the output from streams and ponds inside of Path Explorer as construction zones and polylines that you want to avoid or that have higher crossing costs. But this is really, really useful for understanding the presence of streams and ponds in your tin. Flow paths is another one and our final one in the official hydrology dropdown. So this one, you can determine all the flow paths from either a particular point, as shown sort of on the picture here on the right, or from an actual a linear feature, and you can understand that, what's happening in terms of the flow paths. So the last piece of functionality in the hydrology toolkit comes on inside the feature properties panel, and this is hydro enforcement. So without hydro enforcement, hydrology tools just consider surface geometry. So what hydro enforcement does, it allows flow to travel through a feature rather than just on the surface. So this makes it easy to account for flow through things like culverts. And so we'll be talking about that at length today. And a big part of our example and sort of that second half is going to talk about culverts and hydro enforcement. So speaking of culverts, there are 2 types of culverts that we tackle inside of RoadEng. One of those types is major culverts. So this is where we are modeling and calculating volumes for culvert excavation and placement, and we're doing this for a single culvert at a time because it is a much more extensive project. We typically do this through a few different alignments. We're getting excavation volumes as well as excavation extents. And this is actually not going to be covered in today's webinar. So today's webinar is really going to focus on the second type of culverts that I'll address in a second, in addition to the hydrology tools. This major culvert has a very well-defined workflow, and we're going to be putting a link to the major culverts inside the follow-up email if you're interested in seeing this. We've got some really excellent content on it, as well as we'll drop that into the video description on YouTube if you're watching that there. So the culverts that we're going to be tackling today are minor culverts, and these are the ones that we are able to add really quickly through the culvert editor panel in the location module. So the location module, and if you can see it over here with my mouse, the location module includes that culvert editor panel. We're able to add culverts at a particular station, and then we can control some of their properties like their structure type, their skew, their class. And we can also do this one at a time, or we can do it at intervals. And so as I pass it over to Matt, that second part where we look at the workflow for a road project with a culvert and hydrology sort of united together, this is going to be a major part of it. The culvert editor panel itself is a really simplified approach for culverts, and it makes it really quick and easy to add them in. So I think I've got a couple minutes longer than I was supposed to. With that, I would love to pass it over to Matt. Yeah, and we can get into the live demonstration.
All right. So thanks for the intro, Aaron. And as promised, I'm going to walk through an example. And we're going to use this example as more a means to explore the tool, especially to start. So at the start here, we're going to look at, well, an existing topo surface with a bunch of roads, some failures, and we're going to see how the hydrology tools work with that. And then the latter part, we're going to switch over and look at how we can use those more from a design standpoint when planning our roads. Yeah, so just starting up terrain. I'm going to click Insert, and I'm going to bring in my DEM. So could be DEM, could be LAS. We're going to hit that. I'll hit OK. And this is a fairly large area, and I'm going to just thin down my data here a bit. They're just making it a little lighter without reducing my quality too much. So as I guess for those of you that are already familiar with our software, well, we're going to want a surface to do our analysis on. So I'm going to click Terrain Modeling, Generate. Usually I generate contours here. I'm not going to generate contours just so we can, well, I'm going to use the 3D view a lot here today. So we're creating our tin surface. And ta-da, we've got, well, a good chunk of ground with a lot going on. So with that being said, just in case anyone's familiar with the area or whatnot, I've never been there. It's a fictional project as far as I'm concerned. So with that, if I make the wrong assumption, just yeah, it's using it as an example rather than focusing on well, the actual site. So we've got our topo. I'm going to add in an image. So we could use our live maps tool. I'm going to just add it in as a background that we already have created. Save, waiting for the download. And there we are. And here I will apologize. Some of the imagery is up to date and other parts of it are not. Yeah, so we've got kind of the concept or the data that we want to analyze here to start. So let's actually look at the good stuff, the stuff everyone's here for, and we'll start to talk about hydrology tools. So with that, I'm going to start with the streams and ponds tool. It's kind of a nice tool to explain what's going on and the parameters that are common amongst these. So as Aaron introduced, the software is considering the terrain surface as a raster, so a series of rectangular cells rather than the tin that we actually have modeled, which is a series of triangles. We've got a minimum pond area. So with that, we're going to any flat areas where we expect there to be ponding water, just to avoid having a bunch of really small polygons. We're setting a threshold for what gets generated there. And then we've got our stream drainage area. So with this, as we're considering those cells, well, consider it as if a drop of water landed on one rectangular cell, well, it's going to flow to the lowest adjacent cell. Now, as far as streams and ponds are concerned, once the contributing area, as that flow moves down the watershed, reaches this threshold value, well, it starts to generate a stream vector. So this is one of those things that you may find, depending on your location, that different numbers work better than others. And for me, I'm on the East Coast, given my climate and geology. Well, a good rule of thumb for me to start with is 7,500. I'm going to crank this up here a bit. And I'm going to crank down this depression fill depth. And we'll hit OK. And having this sync in the background, once we get going with it, some of the settings I'll use will speed this up a bit. With the really small depression depth, it's going to take longer than some of the other stuff that I calculate here. All right, so a few things to note. Well, let's look up here. While our streams don't go very high up into the watershed, and we clearly have channels, the one thing that I can take from that is, well, my stream drainage area is probably too high. The other thing that we can see is, let's go down to the bottom here. We've got these not continuous flow vectors. So this one terminates right there. And the reason for that is there's a depression. So that, oops, wrong one, but it's a parameter that's consistent. That depression fill depth, it basically sets a maximum depth that we can fill in those depressions and allow water to continue through. I'm going to rerun this with kind of more reasonable numbers. And we'll go, well, we can leave this plenty deep. It'll still generate the ponds. And let's go 1,500 or 15,000 for my stream drainage area. We'll hit OK. And well, we've got more streams being generated for, well, we've used a smaller stream drainage area. And then down here, that flow is now continuous. It's filling up that little area where it would pond and continues downstream. And here we can see, well, that last spot that we showed, there's a small depression. That small depression was less than our minimum pond area, so it didn't get displayed. But this one here, we've got a pond that exceeds that value. So we're at 64 square meters. And just a note, I do have area reported in hectares, but it was just so small that it's not populating due to the number of decimals I'm reporting. So in a nutshell, that is streams and ponds, and we'll continue along here. So the next item that I'm going to cover, streams and ponds get used on lots of folks' projects. The next one I'll cover is probably going to be less commonly used, but it's our watershed tool. So our watershed tool is going to delineate the catchment areas for all the pour points or spots where our streams terminate, given a tin model. And here, if we have any really small ones along the edge, we're grouping them together based off of a minimum watershed area. Usually, as we jump back and forth between various hydrology tools, we'll typically use the same values for cell size and depression depth, just so our results make sense across the different features that we produce. So I'll hit OK here. And we can see we've got, well, some polygons. So as I said, everything's being tracked to where it either empties off the model or where streams terminate. So this one, this big area here, well, it all goes down and flows out right there, whereas this stream all flows out through there. So yeah, it's not going to be as commonly used on the nitty-gritty project basis, but if you have different requirements depending on which side of a watershed you're on, if you have community watershed stuff going on, it's a useful tool for that. It's also just a useful tool to help visualize where the height of land is. Now, these features that we're generating, well, sometimes you say, oh, I don't want to see that anymore. We've got an idea for it. So I'm going to just hit delete. And here we can see in version 11, we got a bunch more options for what we can delete without having to individually select them or select them by name. So delete all my watershed features. And there we are. So let's do a little more poking around here. So our next tool on the hit list is going to be, well, let's calculate our drainage area. So instead of that watershed tool where we look at it from kind of as a whole, we're going to look at it as a, well, I want to know how much flow contributes to, in this case, this current point. So for that, we've got our drainage area tool. So once again, I'm going to use the same cell size, same depression fill depth. Here we can include a drain radius. So in this case, I've clicked on a stream. I'm not worried about adding an extra tolerance on that. But if I was clicking somewhere along the slope and I wanted to make sure I got the lowest point within a set radius, well, we can use that drain radius as a bit of a tolerance to help deal with any imperfections of where we might set that point. Aside from just generating a polygon for the drainage area we'd like to look at, we're also going to generate a few other features. So we can create a centroid for that polygon if we're just interested in seeing where that's positioned, and then calculating the most hydraulically remote path. So our streams obviously are flow paths, but they go up to the watershed or drainage area boundary. The most hydraulically remote path will be the longest path from that drainage area point to the boundary of our watershed. We can also select to do this based off a feature, but I'm going to just use my current point. We'll hit OK. And there we are. So we've got that. We can click on that feature. We can see, well, how large of an area is that we're dealing with. We can click up here, we see the most hydraulically remote flow path, and we can see our length is about 2 kilometers. We can fire up a profile of that if we want to see a profile. And oops, if we wanted to, we could cut sections across it and well, export that feature in the sections to something like HECRAS, in which case we can export a .geo file for that. So it's easy to do that more detailed analysis if needed, or if you're doing like a river study. Yeah, so we've got our drainage area. Let's go over here and, oh, where should we do this? Well, I guess it doesn't really matter. Let's just create a new feature. I'll show this with something more interesting later, but test, sure, we'll drop that there. And so kind of the same but opposite. If we want to calculate a flow path from a certain point, well, we can't. So I want to know where my water goes from that point. We can see, and I'll click that feature that we've just generated. Well, that's the path it's expected to follow. So that's kind of the overview of things, and I'm going to have to hustle to get all the stuff done that I wanted to get done. But let's look at this in a little bit, well, a little more technical example. And with that, I'm going to just bring in a few other features. And I don't want to see this anymore. So I'm going to dump in my roads, and this is just going to add a little context for folks. Oh, and did I? Yeah, grabbed the wrong one. All right, and we'll drape those guys. We'll set this on the ground. So context where things are at. I've also got some recent failures. So I'm going to bring in just another set of features rather than drawing them in, which I totally could. But yeah, sake of time. All right, and we're going to look over here. Now this is something that, well, I'm going to just click this guy here. And so aside from just the, well, figuring out how large you should make your culvert based off drainage area and flow path, we can also assess how we're interacting with the terrain. And here we're going to kind of look at it from a context of existing infrastructure. With that, we have the benefit of hindsight, and then we'll talk about this as we get into our design stuff. So this feature, recent failures -1, I'm going to calculate a drainage area to this point. Oops. Or sorry, this feature. And with that, we've calculated it, and that's the area that's contributing to this feature that we have delineated. So if that's delineated properly, well, this failure is, I guess, hydraulically remote from the road. Now, if that failure was caused by the, well, maybe undermining the toe, well, we can use that same drainage area tool. we're going to see how the roads upslope of this interact and capture and redirect our flow. So here that looks all good and normal. And then for this first road, well, we can see we're catching a bunch more flow than we probably would have without the road there in the ditch. Same with the other side. So rather than just being a little polygon like that, we're getting a whole lot more area off to the side. And then we go up even higher and same thing. So being able to account for that kind of merged surface is going to be useful. Now this one we'll just assume that the topography has it correct, and we will jump back over to another side here. And let's look at this guy here. This is going to be my segue to introduce something else. So if that were my failure, well, it might be reasonable to expect my road had something to do with that. So same thing, I'm going to use that drainage area tool, drain to current point. I'm going to leave a little buffer on this in case I'm not at the right spot. And we can see, well, if we just account for the topography, it's probably not accurate to what we have going on here. So I'd expect there's probably a culvert there and probably a culvert up here somewhere that's contributing to us capturing even more flow than what we've modeled. And that's kind of our segue into hydraulic enforcement. And we'll get rid of those. So I'm gonna, once again, cheat, save, adding things in. I'm gonna just add in a shape file with some stuff already delineated. I'm gonna make this an arrow so we can see that. That is, direction is important here. So I've got these features and I'm telling it that, well, if I make this a hydraulically enforced feature, my flow is not stuck in the ditch. It can hit that feature, flow through my road prism, and continue down. So now even if we generate streams, we'll notice that our stream vector changes here. See, so we've got flow coming from the outlet of that one, flowing down to here, and away we go. And if I want to see, well, how much drainage area am I actually capturing from that, accounting for my hydraulically enforced features? Well, we can come in here and I'll just run it from that current point. And we can see, well, that makes sense. We're going all the way up here and that flow is coming down. So I am, chewing up more time than I expected. I'm going to switch gears here and we're going to look at it. Well, how do we account for our actual road surface as we're designing our road and those culverts that we're placing in our road? More from a, well, rather than hindsight, from a looking ahead perspective, making sure where I'm discharging flow, I'm aware of where that flow is going, and so I'm going to hit File, Save As. I'm going to call this Topo. While that saves, I'm going to just open up location. And we're going to reference that. So new, we're going to reference our topo surface. So a lot of this is going to be the same process as well, using RoadEng that many of you are aware of. I'm going to just start with a single point. And let's see here. All right, and I'm going to kind of cooking show approach it here, but we'll just quickly run through the gist of the process. So if I'm designing a road by hand, not using our new Path Explorer tool, I can click in my alignment in the plan view. I can visualize all that good stuff that I want to visualize. So I've got my 3D view here. If I'd like, I can say, well, I also want to see those features in my 3D view, so those flow vectors that we have. And here I'm going to just quickly start clicking around and working my way up the hill. So we're going to do that. As we do this, we'll zoom in, we can see our profile. So making sure we're putting the road where we like, interacting with the terrain, being aware of how we're interacting with the terrain as we do it. And clicking right along. Now that's going to be too steep, but as I go, I can add in my curves. Can add in my vertical curves. We can change our cross section to be representative of what we'd like. So we can control that in our templates. Of course, the hydrology side of things and where we put our culverts, the ditch is going to be an important part. So we can change the size very easily just with a tabular input. And we can add pipes. Now I'm going to skip ahead so we've got something more interesting than just what I have here. And I'm going to insert a road that's a little further along than the thing I've just quickly clicked in here. Oh. And I guess I should switch that over. And so all I'm doing here is I'm just, rather than clicking in an alignment from scratch, I'm bringing one in that I've already messed around with. All right, so this one, we've got our road going up the hill. Actually, I'm going to rejig this here. and I don't like the skew on that, so I'm just going to reinitialize. So we've got this going up the hill. And we can see, well, I've got various locations where I've already added in culverts. So here I've got a pipe about there. We can see our cross section where that's at. We can see it in our profile. And I'll add in one extra pipe here at the end. So I've got a bunch for this to be interesting when we do our analysis, but I'll add in one and it's kind of all the same beyond that. So I'm in my culvert panel. I'll click add. So we've got that. Now we can adjust things if we'd like to adjust things. I'm going to just zoom in so we can see this. So my pipe is a 400 mil pipe. If I want to change that diameter, we can, and we could use our drainage area to a point to calculate what's an appropriate diameter for that, and calculate the longest flow path to get our time of concentration. So we've got 1200. We can add in a sump if we'd like. So here I've got, well, vertical offset 1.8. So my default ditch isn't going to require a pipe there, but I'll say, well, let's add in a ditch width of 2 meters, go depth of 2.3, 2 meters wide. I'll hit OK. And here we can see we've kind of forced that into well, adding in a sump. We can control the position, or I guess the skew, I should say. It's all position related. So change the skew number. We can see how we're interacting with things. I'll take it back to 90. Change our gradient. So if I want that to match the crossfall, we can match the crossfall. And if I wanted to change the length, I could also change the length. And if I wanted to change the attachment point, so right now it's set to match my ditch bottom. If I wanted to make that something different, I could, just with this option here. Now, the I guess direction I'm going with this is taking this design surface with these design culverts and actually including that in terrain when I do my analysis. So I'm going to hit File, Save As. Well, I guess just to make sure I don't do something funny, I should probably save this as a DSNX file first. And I'm going to, now the kind of this part that different than just saving the file as you normally would, I'm going to save it out as a terrain file. So I only want to export my current horizontal alignment. I want to include my culverts. I'm going to create a tin at the same time, and I'm going to edit in terrain. So we're going to hit OK. Terrain is going to pop open, and this is going to be a surface of just my road. So there we are, we've got our road surface. So we're going to eventually merge this into our topo file. But we want to account for those culverts as hydraulically enforced features. So I'm going to do a couple things here. Select feature by name. So all these example culvert features. So example is just my alignment name, and then culvert. And these are the facet features that we use to model the culverts as solids. So I'm going to just turn off the display for the plan view so it's not too cluttered. Now, the feature that I am going to pay more attention to is these culvert bottom features. So I've got those selected. I want to see the direction of these features. So when we're using hydro enforcement features, the direction matters. In this presentation we're giving, our culverts are, well, culverts. We can use hydro enforcement features for other things. If we had a pit with a sump in the bottom and we were pumping out of that sump, well, hydro enforcement features can move uphill. So the direction does matter. Set that. So we can see with the arrow, the direction of those features, they're all pointing the wrong way. So they're pointing uphill. So we're going to just right click, modify, reverse. And now they should go the way we'd like. We've turned hydro enforcement on, clicked apply. We'll hit save. And then we're going to switch back to our topo. I'm going to save this as something new. So topo with road. And I'm just doing that so I don't save over my original ground file here. And we are going to merge. Well, actually, before we merge, I'm going to get rid of all these streams. We're going to do our merge. So the merge is a cookie cutter operation where we're going to take this guy here, cut out all the LiDAR data within it, and I'll merge that into place. So that's going to take a moment to think.
And while that thinks, I'm just going to jump in, remind everyone, if you've got some questions, please, type them into that GoToWebinar panel. And we're sorry we're going over time. I guess it wouldn't be a SoftTree webinar if we didn't go over time. So type your questions. Thanks for staying with us longer.
Sorry for going over, folks. I should have been on this. All right, so we've got our merge exercise done. We're going to remodel our tin surface. All right, so now that road is part of our surface, and we've got all the features that we'd like in there. We can click streams and ponds. And there we go. So we can see our streams are allowed to move through those surfaces. If we want to run our same example here with the drainage area to our current point. Well, we'll notice that things change in the upper reaches. We're redirecting a bunch of flow. So we've got our pipe, but everything after that switch gets pushed off over here. So it does represent an increase. So we've got that. And then if we wanted to, we could do our drainage areas really quickly to the our culvert features. I'll add those in there. And I won't remove my existing, we'll just go with that. I don't need a drain radius though. And there we are. So we've got flow going up the hill, and we'll look at what that means here. So here, that flow area, we've got all the water that's, well, generated below the road, but then we've got that culvert here, and that continues up to there. So pretty quick to calculate all those different drainage areas for our features. And with that, I covered the stuff I was planning to cover. So sorry for going over.
Awesome. Well, thank you, Matt. We're going to transition into some questions now. If you're able to stay with us a little bit longer, there looks like there's some great ones here in the list. So the first question is it possible to display natural drainage in the background?
Good question. So yeah, let's look at how the two deviate. So plan options, I'm going to just add in the, oh, we could do it either way. I could add the new drainage into the old or vice versa. We'll focus just on the streams because I don't have the same polygons there. So just to avoid confusion, I'm going to get rid of these drainage areas and drain areas, centroids, sure. So we'll just compare our new streams to the old streams. Go plan options, background, add, and let's grab our topo. Now with this, just to be able to tell what one's the old versus new, I'm going to, well, I'm going to turn off my washout, but I'm going to override the color of the features in that file. So we'll go something quite different. And this would have been, I guess, a little more interesting to go the other way. But yeah, there we go. So here where we're redirecting flow, well, we're intercepting the flow that contributes to these guys here. So those, well, we're changing the topography of the site. We're intercepting the flow that comes along here. And I can see here, well, I probably should have added in a couple more pipes to preserve those natural flow paths. Yeah, alternatively here, I'm just going to delete this just to see it. But we're capturing flow, channelizing it, and pushing it onto the hill in one location. So we can see that we're actually likely going to, well, generate a concentration of flow that may channelize and create a stream further up than the original. So yes, we can add it in and compare the two. And all these features, they're still terrain features. You can manipulate them, modify them, copy and paste them over to separate terrain files, work with separate instances of terrain at the same time. So yeah, pretty easy to do your comparisons.
Awesome. Thanks, Matt. Let's move on to the next question. So if adding an existing culvert shapefile to terrain, is there a way to automatically choose the direction of the culverts to downhill in order to ensure that the direction is correct prior to using the hydrology tools?
Um, hmm. There's a few different ways you could do it. One would be to just drape the features, so the inlet and outlet are set on top of the surface. Um, that yeah, that's probably the easiest way, provided that the inlet and outlet are in the right location. Yeah, and then if yeah, trying to think, is there anything else worth noting there? Yeah, if you had the yeah, I think that's probably the easiest way. It won't make it more convoluted than that.
Okay, great. How can I export only my streamlines?
Okay. So if we wanted to export this, we can export it in a variety of different formats. I'm just going to right click, select feature, um, by name, sure, and we'll go down here, and I guess they're called stream. So stream lines are the actual lines. If we go down a little ways further, stream ponds are the areas that we have ponding water. We can highlight this here, select, and we could have done our advanced select and just typed in stream line or stream L asterisk and got them that way. But we've got those selected. We'll click File, Save As, and we can name them whatever we'd like and change the format to any number of formats. So I'm going to just say stream, and shape will be a common one. So exporting to shape. Well, polylines, we just want our currently selected features, so we'll turn that on and away we go. We export just our streams that way.
Awesome. Let's tackle one more and then we're going to wrap it up. 15 minutes overtime probably. So thank you all again for your patience with us. The last question, if I generated my tin surface and now my hydrology features are flowing to the outside, can I fix this?
Oh, yeah, so if you wanted the tin edge to act as like a dam and not allowed to flow to go to the outside of it, you don't have to remodel anything. It's just a matter of, well, allow flow to outside, turn that off, and the boundary is going to keep flow from going off. So you'll end up, well, in cases like this, you'd have ponding around the where that terminates. So hopefully that answers the question.
Perfect. And if that question asker has any other questions, drop them in the panel. We will, reply to that one over email. So thank you everyone for being here today. We're super pumped for next week. Version 11 release day happening next week. If you have any questions, reach out to our support team, support.teams@softry.com. We'd be happy to help you. Have a lovely rest of your day. Thanks, Matt. And
Cool.
thank you again for being
Thanks.
here. See you,
Thanks,
everybody.
everyone. Bye.